Check the stream. I'm likely on. Hi, people. I'm just checking that this stream is actually working before I completely massacre myself and start talking and basically present an empty screen. I've been known before to just checking that this stream is actually working before I completely massacre myself and start talking and basically present an empty screen. I've been known before to just checking that this stream is actually working before I completely massacre myself and start talking.
Cool. We are on. This is working. The stream is working. I'm gonna try and make it a shorter stream than yesterday. I'm gonna try and be clearer than yesterday. I think I did some stuff that was not clear yesterday, and that ended up getting us a bit more confused than we are. Okay, cool. So what's the status of our project? So yesterday we managed to go through the existing code. We didn't write a lot of code. We did a bit of debugging. We managed to go through the existing code, and we saw how we've set up SPI and how we've set up how we need to do what we need to do to set up the accelerometer we're using, the LIS3DSH. Okay, cool. So what we were going through yesterday was basically we were having problems getting the how do I say it? Getting the values out of the registers. And let's look at the register description. So who am I registered? The who am I register should be 00111. So that's 3F basically, which is 111 0011 111, the 41. So that's 3F. So what were we trying to do yesterday? What we were trying to do yesterday was so okay, 11 binary for 3, 11 11 binary for F, so 3F. What we were trying to do yesterday was read one of these three constant registers, you know. So these three constant registers, info 1, read only information fixed at 0x21. Info 2, what is this? Info 1, read only information fixed at 0 cross 21. Read only information fixed at 0 cross 00. Who am I? Read only information fixed at 0 cross 3F. So basically what we want to do is find out that our SPI is working and is communicating with this device. And then once we know we have SPI working and we're communicating with this device, we can now go forward to implementing the operation of the device. So we do like a startup sequence, we get the device to start, and we set some output data rate, and we enable some access. And after that, after enabling some access, we can now actually use the sensor. It's an accelerometer, and we want to test out reading accelerometer values. Okay, cool. Yeah, so just informing people. Cool. So just inviting someone who had shown particular interest in coming. Cool. So, so what I'm trying to do today, Sorry, I keep looking at my other screen. What I'm trying to do today is use the SPI driver we have, which is the bare metal driver that we built, and use that driver to communicate to this device. So let's look at what the code is doing. Let's see if it's actually doing what we want it to do, and then we can kind of go from there. So we are using SPI1, so I'll label it correctly so that it actually ends up working. I want to go through all my red lines and fix all my squiggles, so that I've done sanity checks. If let's be honest, if that's okay. That needs to be SPI1 init here. Okay, cool. So I've done the sanity checks, and this code appears to be working. Forgiving some sort of catastrophic failure that this should work. Today should work. So most of today will be spent refactoring and actually structuring out a driver from this existing code. So let's look at the current existing application quickly, so we can kind of go through it. So we have the system is initialized with default clock, so that means basically we're getting into main without doing anything to the clocks. And for STM32, if we use the onboard ROM, we'll basically get our same setup of, I think, 16 megahertz. And then we have a SPI1 init function. Let's look at that function. SPI1 init function. What go to definition? It's fine. We'll find it. So SPI1. Cool. That's why there was an issue there. So let's quickly start debugging this, just to make sure it builds properly. If I go to terminal and I go to ITM bundle, we should get that print. Cool, everything's building. So stop the build right now. Let's look at the code, and then let's do. So what is SPI1 init doing? It's setting up Mercy, it's setting out MISO, it's setting up the clock, and it's setting up the chip select. And then once we've done that, we set it up. We're using PA6, 7, and 5, 6, 7. Set up the Mercy, MISO, and clock, and then we're using GPIOE PE to run the to do the clock selection, the chip selection, so that we can speak to the device. Cool. So what is this doing? We are setting up SPI1, the SPI1 peripheral, and full duplex communication. Where the device mode is master. We are dividing by 3. So it's probably divide by 16. If we have a 16 megahertz clock, if we divide by 16, we're going to have a 1 megahertz SPI clock speed. And then we have our data frame format is 8 bits. We have clock polarity of low, clock phase of low, and we enable soft. We enable soft. What do we call soft chip select management? Okay, cool. Cool. So that's all. And what happens in this SPI init? Let's go to this definition. It's basically go to the definition here, and what we can see is definition. Go to declaration maybe. Sorry about that. So what we're doing here is basically initializing SPI. I won't go through this. We've done it. We know how SPI works. So, and we have a confirmation that our SPI is working. Now, let's actually look at what we need to do in order to speak to the device. So we're initializing SPI. Okay, cool. SPI1. And then now look, who am I? Who am address? Okay, so the address of this is 0x0F, which is the, remember, from our register table, 0x0F. 0x0F, there you go. It's a who am I register. And what is it supposed to read out? 00111111. So that's 03F, 0x3F in in hex. Okay, cool. So let's try and, I think the first experiment is to try and read these three fields. And if we can get the correct data out of these three fields, then number one, we know our SPI driver is working and our peripheral is working. So now we can kind of start refactoring this into its own driver and start using it basically. Okay, cool. So let's do that. So we have an who am I address of, so let's call this read address for now. Okay, so that it's more read address. So read address. Okay, cool. And then let's say this is read data. Okay, this is going to be read data. Refactor this so that it can be, so that we can kind of just move through a couple of addresses and read data. Okay, okay, cool. So what happens here? Let's look at this. We have a read address of 0x0f, and we make it a write address by ANDing it with 0x80, which becomes 0x8f. And then we do a dummy write. We have a dummy write value that we use, and then we have a read data, which we set it to 0x00. I want to set this to something like AA. The reason being is so that, look, so we have this two. So info here is 0x21. We have info here is 0x00, and then we have 0x info here is going to be 0x3f. Cool. So I'm setting this read data value to 0x AA so that once we read it and we put something in it, if it comes back out at 0x AA, we know we didn't manage to read something into it. If it comes back out as one of the data we expect, like in this, it should be 3f. Okay. And then if we get 3f, then we know it's not what we did. It's basically a sanity check. Okay, cool. So let's read the who am I address and see what we get. And basically for SPI, in order to read what we do, we send the read address, and then we read whatever, because it's a synchronous communication module. So what does that mean? The timing diagram will show that whenever we read, whenever we send data, we receive some data, and it's usually the receiving data at that point is usually garbage, so we don't want it. It's something is going, something is coming back at the same time. So we have a 1 so that we can do some sort of dummy read, and then we do a dummy write to trigger the clock cycles so that we can get our actual read. This is the mistake we were making yesterday. We were only considering this fast read, which would always come out as 0x FF, because it's just dummy data. It's stuff that exists on the line from some other communication. So this was the mistake that we were doing yesterday, and this is why we could not achieve the reading that we wanted. So let's try today. Okay, cool. So let's step through this code, run, start debugging. Okay, so let me select the ITO port so that we can see whatever comes up. Let's see. Step through that. We get system booted with default clock. Perfect. Okay, so what has just happened? GPIO ODR is OXE8. So this means we've I think we've now deasserted SPI1. Okay, cool. Because now we've the chip select has a value in it, because this is 00. There's a 1 in there. Cool. And then we know we have a read address. Let's set the read address. Let's set the dummy read data. Cool. We've set up all our variables are set. We can see all our variables here. Read address is that. Dummy write is that. Dummy read data is that. Okay, cool. So initialize we've initialized SPI. Okay, cool. So let's print that. We've initialized SPI and we're reading from address 8F and the current value is cross AA. Okay, cool, perfect. Oh my word, I love that. How did I manage to do that? I did something and it showed me all the values just now. Anyways, that was amazing. Cool. I don't know how to do that. If you know how to do that, please let me know. I would let me open the chat. Let me open the chat. Docs. Chat. Okay, cool. So I've just questions if you have any. Cool. That's it. Okay, so if you know how to do the thing I just did now, where I managed to open like a little floating window that showed me all the data I needed, please do let me know. Show me all the kind of data, kind of the values of all the stuff, but it's okay. It's okay. We'll find that later. So okay, cool. So let's step on to the next one. Our read address is 0x0f. So we should be expecting. Okay, let's do the next one. So we do a delay after enabling SPI1, and then now we are going to enable SPI. Enable it. Let's see. Enabled SPI1 by making PE3 low, so GPIE is now 000 instead of 0 cross 8. Okay, cool. And that can be, we can remove that just so the next time that line looks the same as the other one. Okay, cool. So now let's send the read address. We send the read address. Cool. We handled SPI TX event. Cool. So let's do that. Now let's receive the dummy data. Okay, that's useless. Yeah, cool. You see, we get a FF. We don't need that. Okay, this is dummy read after our expert. Cool. Now let's go. So dummy read is that we get FF. We don't want that. So let's go ready for RX now. Let's probe. With let's do some clock cycles to probe the SPI. Okay, cool. So now let's actually do, we've sent, let's do our receive and see what happens. Okay, cool. So read data is AA now. Cool, let's do that. Read data has changed 6.3. Perfect, cool. So let's send that out and let's see what that means. Perfect, we get 0 cross 3F. 0 cross 3F if we do binary hex to binary. What does that mean? 3F convert 00111111. So what does that number match with? We got this. We got 00111111. So our SPI driver is working. Let's do a few more sanity checks, and then once we have those working, we can start moving into refactoring this into a driver. Okay, cool. Let's read 0.0 cross 0E and see what we get there. If we get 0 cross 0E, if we read here 0 cross 0E, and then we save, and then we reset, and then we just, do we have a breakpoint somewhere? Yeah, we have a breakpoint there, so let's just play it. Perfect, 0 cross 3F. Ooh, that's not a good thing. So probably we need to stop this, and we need to run this and start debugging. Okay, come reset. I don't care about that. Start debugging. Cool. And if I press play, what do we get? RX read 0. Perfect, 0. Yeah. Okay, that's cool. So what? Because we were reading 0 cross 0E. So we should get 0 cross 0 E. It's all 0. This is fixed at 0 0. Okay, so let's look at the next one, info 1. Let's look at info 1. 0 cross 2 1. So last I need to check to make sure our code is working. Last I need to check. What address is that? 0 cross 0D. Cool. So 0 cross 0D. 0 cross 0D. Cool. Stop. Okay. Run the whole code again. Perfect. Let's go to here. And then we want to press run. And we should get 0 cross 2 1. Perfect. What does this all mean? Our driver works. We can read from our accelerometer. We can read from our accelerometer that's on device. Okay, now, however, look at this. Our code right now is quite a little bit, let's stop the debugging completely. And now let's go into the code mode. Thank you. Perfect. So our code right now is a bit mixed up. How do I explain this? No. Our code right now is a bit mixed up. Fine. Sorry. I shouldn't be messing with that. Do we have any questions so far? No, not at the moment. Okay, cool. So our code right now is quite mixed up. We have an SPI driver. Yeah. However, I think we could probably make it so that our code has an accelerometer driver. And that should enable us to have a very, if we had all the accelerometer code out of our super code or our super loop here, what would eventually happen is we'd have a very small file that we can rush through and dig in as we need. So let's do that refactoring, put the accelerometer code in its own self, and then after we refactored it, we can follow through this guide here, where we can now, because we are reading stuff, we know we can read stuff and we're getting the information, and we know we can write stuff. So what I want to do is separate the code so it sits by itself, refactor it so that it sits out by itself, and then we can now start having some sort of API to speak to our accelerator code, accelerometer from the device. Okay, cool. So let's add a couple of files. So I would include new file. I would say this is 32F47 LIS3 H. Okay, and then here I would say new file 32F47 LIS3.c. Usually what I do in these files, I include, I'll do like a function. Let's make a function here. Void print say here. Okay, cool. And then I'll take this function and I'll go in here and just list3. Okay, rename this list3. Okay, cool. And then I'll say control V and I'll come here and I'll do that. And then probably all I need to do is hash include stdio.h. Cool. That good? Okay, cool. So, and then you want to go here and say printf. This is from LIS3 driver module. Okay, so let's go make sure this driver module can be included and can be used. And then once we can do that, we'll start transplanting code here and see what we need to do. How do I need to do that? So hash include drivers, and then here, ink, and then here, there's 3. That's perfect. And then let's first thing we're just going to say here. Cool. So if we can run this, then we can start transplanting the code. Let's see. Start debugging. That might work, that might not work. Ooh. Cannot find that. Let's see. I probably need to modify my make. I need to probably modify my make file. Okay, perfect. So if I do drive, so yeah, drivers src (32) F47 LIS3 .c. Okay, cool. So let's see if this changes anything. Start debugging. Ooh, this kind of means we're good. Okay, cool. So let's ITO, run that. Not good. I know what the problem is here. Stop. Run. Start debugging. Okay, cool. Run that file. Let's see. Perfect. So we're running code from the driver module. Clear git status git add drivers git add cmake git commit add module for the LIS3 and modify cmake to include it. Okay, cool. Push. Perfect. So now let's actually see how do we transplant all of these issues into so that here we never include the SPI. What do we need to do? So all this, first of all, SPI init, SPI1 init should happen. This should happen in the this should happen in the accelerometer driver, because we should be enabling this peripheral where we're using it. Cool. So that it's kind of clear. Okay, cool. So let's go into LIS3.c, and then in here, let's do actually, we can't move it from here straight. So LIS3.c, let's move all of these, I think, these globals. All these globals do not need to be here. Okay, cool. So LIS3.c, let's move on that. Yeah, cool. And this means this should include SPI.h. That should fix everything, all our inputs. Cool, perfect. And then in our make, that's okay, that can be there. That can all be there. And then we need to move this SPI1.init init. Oh, that's even better. That's fine. SPI1.init. Let's move it there. Let's move this guy into LIS3.C. Okay, so let's move that there. I think this should be able to be called from LIS3.C as well. Okay. And then we need to know SPI application event callback. I mean, really, to be honest, we're not using this. And this handle should also move. Why is this handle here? This should not be here. That should be okay. What does that fix? What does that break? SPI1.init shouldn't call this here. And this now, it remains for us to send this data and SPI event, SPI handle event, SPI event application. Okay, cool. So even this one, actually, to be honest, even this file, even this piece of code should move here. And I will explain why later. That doesn't have that. And that means come here, and that means I need to delete that. So here, probably, what we need to do, application callback, remember to check that this is SPI 1 below, so we don't affect the other SPI stuff. Okay, cool. So that seems to be working. All this code might end up just breaking, to be honest. Okay. So what do we need to do here in order for this to work? I think what we need to do here, so it just occurred to me that we need to treat the SPI, the LIS3 accelerometer, as though it is how do I say this? As though it is a struct on itself. But that we'll get to that later. For now, what I want to do now is I want to think about the APIs I want to expose from the LIS3.c. So the first thing here okay, cool. So we have a couple of there's a couple of functionalities that we can add. There's a couple of how do we say this? There's a couple of functions that we can add that will improve that will make our accelerometer usable. And if we think about it, so void init LIS3. Okay, there's that. And then there's void write read. Yeah. Okay, yeah. Let's put the nouns first so that we know. Noun and then what we're doing. There's 3 init. Okay. And then there's LIS3 write read. Okay, there's that. And then we have void LIS3 read ID. Okay. Okay, and then we probably have void LIS3 read access. For now, what do we want to do? Yeah, we want to be able to initialize it. Okay, once we are able to initialize it, we want to be able to probably read an address out of it, write read. So this should be this should take uint 8 underscore t address. Do I have to import? Yeah. Perfect. So let's include that. That takes an address. Init, what does init take? Init could just be itself. Should probably return a uint 8t. Okay, cool. And then that should read, write read. So this should probably int 8t as well. And this should also return the uint 8t of id. And then this should also return uint 8t because you're reading the access. But we'll get to all of those. We'll get to all of these functions as we move. So for now, I think let's start with init. Okay, and eventually we will have how do we say this? Eventually we will have. I'm mistaken. Let us first start by implementing. I'm mistaken. It's hard to think and live code at the same time, but if I don't practice, I'll never get this. So let's go with the write read first. Let's implement write read. Okay. So LIS3.h, LIS3.c, let's implement write read. Okay, cool. So what does write read mean? Basically, write read takes the address, some address that we want to write read, and then it does this, what we did here for that address. Okay, and then deselect at the end. Cool. So it does this sequence. Let's do that sequence. Let's see. Write read. Let's do that sequence. What sequence is this? We get that. Perfect. And then we have a read address. Right, read address, and we have a dummy write. Okay, so dummy write needs to be also basically also defined here. So just a moment, am I including my own header? Yeah, it's fine. So I should include 32. Okay, cool. And then I wanna put dummy read. We've got to those ones. So I want to go to LIS3.h and I want to put these here. And my mistake. Let's do this from C first, and then we'll put them in H. So delay here. Delay here is okay. So I can go like void. Do not write delays like this, but since I haven't implemented a timer, I'm just gonna do it this way from uint 8 t I equals 0, I less than 200 and 200,123, and then I plus plus. It's just a busy wait, some sort of busy wait. Okay, cool. Okay, cool. So just a busy wait should be timer delay, but it's fine for now. That fixes our delay issue, and then we want to move dummy right from here. Dummy right. It's cool. Dummy right. Read data. Yeah, let's move all of this from here, and then we'll go LIS3.c. Okay, cool. So SPI init. Okay, so cool. What does this happen? What does this do with read address? It gets read address, and then you can actually pass in. You should be able to pass in you int. I want this to be a location. So I want this to take sorry, my C is failing. Accept pointer C. It's just a little syntax here, honestly. So I want to pass a pointer into this thing so that I can read it. So okay. Yeah. So I want you int 8 t star read address. I can delete this, okay, and then I can say read data. What do you mean? That this is this string. Okay, let's look at what I'm doing wrong. Like that. You want it to be that way. Ah, conflicts. New int 18 star read data to address. Okay. Let's read write. Okay, cool. Let's go see. Read write read data. So we do all the same stuff and unread data. It just should be. No, we don't need all of this logs right now because the logs are doing less than what we actually want. So remove that. I don't know what that is. It's okay. So I don't want the logs, but I also, once we're done with the reading, I want to disable this SPI. So that is ES. Okay, cool. So that's disabled. The as delay. Okay, just give it a moment, and then to Z, and then let's deassert PI1. I'll kind of do a void. The API is evolving as we say, as I built it. Okay, cool. So let's look at this. Let's look at all of this. What is needed here? No, it's okay. That's okay. We'll fix that when we come back. It's good. So we have all of this LIS3DSH. Okay, cool. And then we have some, we need to have some sort of initialization, so init. So I'll make this a void as well for now, before we add it, just so I can test everything. What is this? Void list3 init. Let's implement that. So void list3 init. Okay, cool. I don't really need this guy. It's gonna break some stuff, but that's fine. List3.h, remove that. That's fine. List3 init. Let's do list3 init. Okay. So let's run that fine. Cool. So if we just do SPI1 init like that, obviously choose init communication lines. Yes. And then obviously let's go here and choose down here we should like do list3 setup. So choose data rate, choose filter, enable access. Okay, cool. We'll do that. But we do know once we have SPI1 init done, we can basically just read an address and it should give us whatever we need to do. If I'm doing this right. Yeah, this is just because this is an address, it will work. Okay, so we basically have a very minimal thing. We can test this driver as we have transplanted it from the main file just by doing the same initialization we had before, and then say reading the who am I. We can send a read address of the who am I and give it a read data and see what happens. Okay, cool. So say here this does not work anymore. Cool. That can stay, that can stay, this can stay, this one can stay, this one can stay, this can stay. Cool. So let's this is fine. All this below here is kind of unneeded. It's just a while loop. But let's do all the SPI stuff here. So we need a read address of 0x0D. Okay, cool. So that's the read address. We should actually do this, all of this inside. We should do this inside I'll do it and explain it as I do it. So once we get an address, we should make it a read address. So here. So you can say read address equals to and we can just remove that. We can technically remove all of that. Okay, cool. So we are ending it with we basically are setting a bit in the read address so that we can use it. We can make it. We're making the read address usable, if that makes any sense. Cool. We're making a read address. Okay. So let's say you int 8_t read address is equals 0x0D or 0f. Let's do that. Cool. And then we want to say you int 8_t read data is equals cross A. This is fine for now. This actually fixes everything that we want. So let's print that, printf initialize SPI. So first of all, and then now let's do LIS3 init. Cool. So initialize that. Okay, cool. And then we do a little delay. We don't even need to do a delay because our actual driver code has delays in it. Okay, cool. So what's the next thing we need to do here? Okay, cool. So I will read the data and just print it out, no? So LIS3 write read. And the address here should be read address. And then this should be a point our where to read to. And so that's going to be and read data. This should, barring, I don't know, this should work. So let's try it. Run. Start debugging. I know what to do. I know what to do. Just a moment. I need to go to my CMSIS folder, into my include. Ideally, I should just use a proper delay, but I'll get to that. That's okay. And then if I do that, it does that too. Run, start debugging. So The thing is not working because we are defining main too many times, delay too many times. So let's just use that, remove that. And then let's do some sort of little run again. And it's gonna complain because this is needed somewhere. Where is the issue? Let's see. This 3.h. That debugging. Okay, does anyone see the issue I've been doing? If you don't, if anyone's there, redefinition of delay. I want to clear all of this. And I want to do run. Okay, I'm going to do away with the delay. And then I'm going to run that debugging. That's fine. Tell me where is main? Okay, main.c. Let's just put it in. Okay, run start debugging. Okay, STM32. Okay, cool. So we'll get to why that main was broken. So we want to read 0 cross 0f. So basically, ideally, we can get the ID out. That would be nice. Okay. Zero cross 3f. Sent data, now receiving data, current value, blah, blah, blah. Cool. So our driver is working. That's what this means. We managed to push, we have managed to get to the same level that we were before. Okay, cool. So our driver is working right now. It's not very clean, but it is working. So git status here. git add drivers, git diff dash staged. What do we do here? Git commit pull dash n. Okay. So okay, what did we do? We added the list3 header. We added the list3 source file, and then we did a write read function, and then we did some sort of the same initialization of SPI that we were doing before, and then we put our RQ handler and stuff here. Okay, cool. So git commit dash m move list3 driver to its own module. Okay, because now it's all working. And now what I want to do is I recalled, so we have this, you see this, so here's the thing. You see this callback function that we have here? We shouldn't call this here because this it's going, we want to call this sort of like our top level of the application, because this is our application callback. It's not just this SPI. So this could be called if we have this could be called if we have how do we say this? We basically don't even have to implement this. Looking at it, looking at it, looking at it. Do we have to implement this? No, we don't have to implement this, because this really right now just tells us we've done it. We've done some stuff. So if I actually remove that and I go back and I run the code that we've just run, first of all, we get everything. Okay, cool. Zero cross 3F. And I can remove these logs so that, you know, eventually I think it would be quite recommended to build out like a logging system so that you can activate and deactivate some logs, but that is going to be something for a different exploration. So let's go into our SPI code and let's remove some of these logs that are making the logs. Now that we're going deeper and deeper and more of our base of our code is working, we don't need so many confirmations per se. And this is going to, of course, make our debugging quite easier. Okay, cool. So let's run this again, start debugging. ITO port. And I think I have a breakpoint somewhere down there. Cool. So I can't just do play. Oh, perfect. What do we see? SPI is being initialized. We don't need this read of ODR anymore because that was all like sanity stuff, so we can't remove it. But we are initializing SPI. We're asking the accelerometer for its ID. It's telling its as its ID. we have a driver working. So let's clean up. Let's clean up this wherever this log is coming from. These ones are okay. Okay, cool. So wherever this log is coming from, wherever we are reading GPIO ODR. So that's probably going to be in our LIS3.C, and I think that's going to be here. Okay, cool. So that's nice. It's enabled. We can put this here. We can put this at the top here. So we're done. Say setting up SPI1 to MEMS-ARC, and then leave that some space, and then say here SPI1 to MEMS-ARC, set up and ready. And ready. Okay, cool. Perfect. So let's now do something else. We want to be able to do the initialization of this accelerometer. So what do we need to do here? So now we have finally back, our code is finally back to a sane level that we can actually set up the accelerometer and start reading from it. So let's do this. And we need to write control register 4. And we need to write 67H to control register 4. So let's go find control register 4. Which is this? This is the control register. What is this? This control register description. So basically, this is what sets up our how do you say this? Our accelerometer. So we give it a data rate. The default is 000. So that's power down. It's in power. So we have to set the data rate so that it's not in power down mode. Remember, power down mode is when, let me have some tea. So power down mode is when, this is the default one. Power down mode. It's when the device, when is it in power down mode? It just literally when the device turns up. When the device, where's the startup sequence? So once the device is powered up, it automatically downloads calibration coefficients, and then when the boot sequence is completed, it goes into power down mode. Cool. So once it's in power down mode, basically it just keeps the last reading and never updates. So here, when we go to set control register 4, which is address 0x20, if I'm not wrong, 0x20, yes. When we go to set this register, we first of all set a data rate that we want, and then we can make it whether to continuously update or not, and then we can enable whichever accesses we want. At the moment, I'll just enable X, Y, and Z. Okay, so we get something working. But eventually, what this driver turns out to be is we'll build a struct and expose a struct, and then when you're setting up, when you're doing, so basically here, when you call initialize here, you should pass in some sort of accelerometer struct that defines, how much, what data rate do I want? Let's actually define this. Why not? Why do we have to leave this one other day? Let's do it right here, right now, right here. I need to make a type def, or is it what does my SPI one look like? Not a config T. Config T. I don't really need a config T. Yeah, I need a config T. Okay, cool. So let's do let's go here, LIS3.h, and then we can, I will actually copy even that. That's fine. No. LIS3 config T. Okay, cool. let's do that. Let's go to LIS3.h. Let's define this as well. So let's look at LIS3 config t LIS3 LIS3.config t. Okay, cool. And then let's remove all of these and see what we want actually. Okay, cool. So let's look at what we want to set. So we want to set our output data rate. Okay, cool. So we want to set our output data rate. Do all 3-bit numbers cover our output data rate? Or 4-bit numbers? 4-bit numbers. You int 8. You int 4 underscore t. Okay, cool. So you int 8 max for 4-bit number. That's fine. 111 15. So are we allowed to have 111111? Data rate 1111. Okay, what's the data rate? 1001. 1001. That's 2. 9. 9 is the max. So just give me a moment. I need to. It's hard to do. It's hard to think of math at the same time. So let's go here and allow someone to set an output data rate. You int 8 list 3 PR. Okay, and then we have what's the next other thing that you need to enable? Then BDU. You int 8 underscore t list 3 BDU. Just 3 BDU, and then you int 8 underscore t access enabled this 3 access. So we have we have a configurable, we can configure our data rate, and then we can set this data rate to our thing. So let's look at it. So I'm thinking. Okay, cool. Let me see. Any questions? Almost done. This is an hour in, and our driver is almost working, so I want to finish it. I want to make sure it works. So if we get a data rate, and then we get a block data updates and an access setting. So access could be, I mean, it could be 111. It's a 3-bit number, isn't it? It's a 3-bit number. So 111, 100. So P0. I want to do some little conversion here and see what happens. This is X binary. I want to just look at 67 convert. Okay, and then I want to look at bit. So I want to go here. Let's look at this. I want to see. Okay, cool. So I want to see. Okay, how do we come up with this number? So this is 111. Block data up. 111 to block data updates. BDU. BDU is 1 bit. Okay, and then 4 bits there. Okay, cool. So I can do something like, so it is going to be 0. Okay, let's look at it there. 0, 0, 1, 1, 0, 0, 0, 0, 0. Okay, or 0, 0, 0, 0, 0, 0, 0, 0, or 0, 0, 0, 0. That's 8. 0, 1, 1, 1. I'm doing something wrong, obviously. I need to find out how do I, okay, cool. So this is where I'm trapped. So how do I combine 2 8-bit? It's an or binary calculator. Zero zero. Okay, so how do the 0? That's 67H. 67H. 0 1. Let's take this. Okay, cool. I just need to take this. And then I want to take 1, 2, 3. It's not right. 1, 2, 1, 2, 1, 2, 3, 4. Okay, cool. That's 0, 0, 0, 0, 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. That's that. It moved this way. I don't like that. Mm-mm. 1, 2, 3, 4, 5, 6, 7, 8. Okay, cool. Okay, let's do an OR. Perfect. And then let's take this one and then OR it with 1, 1, 1. Calculate. 1 to 3. 0, 0, 1. Perfect. Okay, cool, cool. So convert that. Let's convert that to binary to hex 16. Okay. 0. 7. Let's do that. Cool. Let's just set this up in kind of like a set in let us set this up. Let's use hex when setting this up. So we can pass in. We can either we can do we have hex numbers, we have binary numbers. We can actually also do just decimal numbers. But I'll use hex numbers for now. And then once I get to a good point, I will start using binary numbers. So cool. So we want to set this and we want to set it to 0 cross 7H. So in order to do that, we want to set this 3. Okay, cool. So that we can actually initialize the, what we want to do is we want to initialize the, initialize the accelerometer at a certain rate. Cool. So we have this, and we have that type def struct. This config team. So let's come here. And here we can kind of say accel 1 is LIS3config team. Okay, cool. Idiot! It's the other way around. Accel 1. Okay, 1. So cool. So that's in there. What am I doing wrong? What am I doing wrong? Okay, so that works. Okay, cool, cool. So now let's, in here, let's set up our accelerometer. First of all, can we read config? Can we read config? Config. Can we read this? Is this a read write data? Can I read this? Register table. It doesn't tell us whether I can read it or not, but I will try. Okay, cool. I will try. It's way easier to try and fail or something rather than actually stop and go. See, so list3 config t dot what? Man, accel1 dot data rate is equals. So we did this math already here. We did this math already here. We did this math already here. We want that. We want this number in hex. Binary to hex. Convert 0 cross 60. Okay. 0 cross 60. Okay. And then accel1 dot pdu equals 0 cross 0 0. Okay. Okay. Accel1 dot access is equals so if we just do 1.1 converted to be 67, but 0 0 convert to 0 0 cross 0 7. Zero cross 7. I'll say 0 cross 7. Where's my visual code? 0 cross 7. Okay, cool. So now we've done an init. Here, this init should take accel1. So let's accel1. Okay. But here we should do a ride read on cross 20. Let's do a cross 20 ride read here. And what do I have? What do I need? Int 8 underscore t read settings equals 0 cross ff. Okay, cool. So here I'll go read settings. Okay, cool. And then here I'll go. I'll say you int 8 underscore t for 0 cross 20. Okay, cool. So read address is just that. Oh, read is just we provide that one and we read it, and then write read. So what do we write to that? Write to read. Okay, write read that, and read settings. Let's see, and then once we do the setup here. Okay, cool. So let's go SPIC here, and we have list3.init. No. Accel list3.h, list3.c. So what I'm going to do here is I'm now going to use the lane, and then here I'm going to accept an set up what is it? LIS3 config t set LIS3 config. Okay. And then data uint 8t config is equals to LIS3 config dot er or LIS3 config dot bdu LIS3 config dot access. So we combine all of this into that, and then we want to do a write. I'm confused about SPI write. That's fine. Perhaps there's some explanations here. No. Writing to an address with SPI. It doesn't really matter. I just need to remember how to. Look, it's the same thing that we're doing. I think I can actually. So in order to write to SPI, right? Okay. In order to write to SPI, let's look at what we need to do. Okay. Writing to SPI, writing to them. That's what I'm confused. That is where I'm confused. That's where I'm confused. So let's just come up with all the documents that we need. Okay, cool. Okay, what do we need to write with address, and then that's for reading. Write for address to that. Okay. Okay, cool. So I was quite confused. This is simple. This is so simple. I ran I ran around my own. I ran around chasing my own tail. We have a config here, and we know where we need to write it to. CRL for address is equals to 0 cross 20. I don't need to do a write read. I need to do a write. Yeah, basically just a write. U int 8_t, that, and then we now need to go and do this SPI send data SPI one handle. Okay, let's make a write. Okay, let's go back here and let's copy write read here. Maybe let's do write to which address what data. It's gonna take a normal one. Okay. So let's go implement this guy. So this is the write. Let's do that. And let's implement the same thing we need to do here. Okay. Okay, cool. So, okay, cool. I don't need to do this. So this address, this can all go. Send data, this can all go. And then this will be the address, length 1, that will be fine. Well, I need to receive dummy data. Probably. I mean, I don't really care for it. I can just leave it. I don't need to do this read, okay? It's because it's a read. And then I don't need to do this receive as well. Okay, cool. So I want to send address, boom, and then send. Data. Okay, and then here I just want to do data. Okay, cool. So this should do the thing that we need for us. So here we have the address there, and then we should do these three read. No, right. CTRL4 address, and then want to dump in a config in there. And then we go to main.c here. Okay, cool. So that's that. And then once we do this, accel1, read settings. Okay, cool. This I don't need. This I don't need. Okay, cool. Okay. this 3 config. Okay, cool. So main, let's see, config, that's it. We should read this here. Let's see. C, Control V. Okay, cool. So let's think about all of the things we wanna do. This is all sanity stuff. We can leave it in for now to know that we're reading stuff, but okay. Okay, let's leave that. What I want to do here now is to initializing accel. So let's do CTRL4 and settings. Okay, cool. And then see here, do a right read of that, read address, read of read settings. Okay. And then after we do that, that's probably gonna give us okay, cool. And then let's do the init now. Initialized accel reading address. So this is CTRL4 read settings. What does this do now? This just basically configures our accelerometer with those initial settings, and then we should basically be able to do that. So let's do start debugging. Okay, cool. Let's go to our SWP. Okay, cool. Let's just walk down through this. System has been booted. This is all irrelevant right now. Right, read to settings. Read address to settings. No, let's stop this. This should read control for address. See? CTRL4. Okay. Run. Start debugging. Cool. So cool. So let's go. So read control4 and let's see what it has in it. Not so sure about that. No. I have somehow managed to mess up. I have somehow managed to mess up because now my code isn't working. Here's my issue. I do need to implement my callback handler. My confusion is growing. Okay, cool. So let's implement this callback handler and see if this changes anything for us. Does this change anything? Okay. So let's run, start debugging. Display that. I do not want to stop here today again because I always stop when I get stuck, but I do want to figure out what I did wrong. Basically, we're having a problem because what we're observing now is that our callback function is never called. Run. Run. Start debugging. How? How did I manage this again? And what did I break now? Let's look at initialize probably. probably where our issue is. And run. I know the problem. So I did a very silly mistake. What I did was I removed my SPI initialization code. And what we want to do, and if we want to do this sort of sanity checks here, we want to go to our initialization code here when we do an initialization. So after we do an SPI initialization, let's do that. Let's do this right read here of read settings. Uint 8 underscore t ctrl uint 8 underscore t read settings. Okay, I want to put this. I'll put it here. Okay. And then once I put this here, address. So once I put that there, we want to read that address just to sanity check that we are actually changing it after we fixed it. And then this is supposed to be the address. And then if we read this value should be different from when we do here. Okay, let's run this. Start debugging. I really am just gonna play. Okay, cool. So let's play. Let's come up here. Let's come up here. Let's come up here. Let's come up here. This is really messy and I don't like it. So this is fine. So let's look at it. Okay, I have a feeling. Let's just for once and for all like know that this is not needed. Let's do that. We can delete that. And I want us to run start debugging. And go here and we have everything enabled. So we play. What does happen? Remove that. Okay, cool. And now let's go to our main our good. We're back. It's working. Okay. So I figured today I figured out an issue without having to leave and come back later. So that's a good bit of progress there. So let's see here. So this is SPIing it. Did you guys hear the Did you guys hear the thunder in my wife's scream? I'm gonna try something different in case that's the default value. I want to try and set it up as let's try and set it up as rate settings value. Maybe let's do one. Okay, run that. I don't like that it's not working. There definitely is an issue. Control register for cross 20. The default looks like it should be 0000111. All access enabled, but everything else data rate should be 0. So I'm having a problem getting that data rate being 0. So maybe let's just read that before we do anything. When we read that address, before we do anything, when we read that address, am I missing an explanation? Hey guys, I have to stop. It's raining in my office. I kind of have to come back to this later. Thank you guys so much for coming and hanging out with me today. I have a leaky window behind me. It's a leaky roof that becomes a leaky window. I don't understand. But basically, here it is. So I'm having problems implementing SPI read. This is probably something I'll fix within the next few minutes, and we'll be back with you guys just a moment. Tomorrow we'll do something else. Probably read from the data inside the accelerometer and try and make it so that the data flows into maybe LEDs and stuff. So thank you so much today for joining me in this one. And I hope I did better than yesterday. I'm glad that we found errors and we fixed them while in progress. And that was amazing. Cheers. And thank you so much for today. Cheers, man.